Hi students, welcome back. Today we're going to talk about chapter 70.3a, application of Equilibria. And we're going to talk about Le Chatelier's principle. So for today, there's a worksheet due on ice tables. I'm going to do one more practice example with working with ice tables to assess the K value. And then we're going to start with chapter 70.3, applications of Equilibria. We start with 70.3a, Chatelier's principle. And moreover, we're going to look at the effect of change in concentration. So let's do one more practice with the ice table. Look at the following. We have a mixture of NO, H2 and H2O. And according to the reaction below, 2NO plus 2H2 becoming in equilibrium N2 and 2H2O. There's information about the initial concentration of NO, H2 and H2O, also about N2 because that's 0, there's nothing left. And when we have an equilibrium, we found that the concentration of NO was 0.662 m. And now what we have to do is to calculate the K value. Use an ice table. Okay, let's find what information you already have. You see in bold and italic, that's the information we have. We have information about NO, H2, N2, that was 0, because there's nothing in there initially, and H2O. And we know in my equilibrium I have 0.062 m of NO. So we can fill the entire first row and one cell from the final row. So now what we have to do, we have to find what are the values in my C, the change row. And there we have to use the ratio of my reaction equation. The ratio is 2, 2, 2, 1, and 2. Now we're going to fill in everything. So, because we know the initial concentration of NO and my equilibrium concentration, the delta, the change, is what is changed. And because the ratio between NO and H2 is 1 to 1, see here in the formula, so we can also say the decrease of H2 is the same as the decrease of NO. For the product side, we know the ratio between NO and N2 is 2 to 1. So how much N2 is produced is half of what has reacted here. So 0.038 divided by 2 is 0.019. For H2O, we have the ratio 2 to 2 for NO and H2O, so 1 to 1. So what has reacted for NO, the same amount is produced for H2O. So now we know both the first row and the second row, and then we can assess the third row, because the concentration of H2 is initial minus what is changed. For N2, initial plus, because the product was produced, what has changed. And for H2O, the same, initial concentration plus what is formed in the reaction. So here we have the value. What you have to do left is just plug in all the data in our K, and the K is products of reactants, so it's a concentration of N2 to the power of 1 times the concentration of H2O to the power of 2 divided by the concentration of NO to the power of 2 times the concentration of H2 to the power of 2. Plug in all the numbers you find in the final row for equilibrium, and you have your answer. And it should be about 653. I have a worksheet at the end of this lesson, and there's another practice with an ice table. Okay, now let's move on. Application of Equilibria. 70.3a, and we do it by step. So, one thing we have to remember for K. K is constant, always constant, except when temperature is changing. When temperature changes, K value will change. So we're going to look at 3 different ways to influence an equilibrium. Is by removing or adding compounds, it's the same as changing concentration, increase or decreasing the volume, or increase and lowering the temperature. For the first two, adding, removing compounds, or increase volume, K will not change. This one, increasing and lowering temperature, K will change. We'll see it later. So let's look at the first one, adding or removing compounds. And we're going to do this. It's the Chatelier's principle. And the Chatelier's principle is when a change is imposed on a system at equilibrium, the position of the equilibrium shifts in a direction that tends to reduce the effort of that change. So meaning if I do something on the left, on the right hand side, I will have an effect. We'll see that later. So adding, removing compound. Same as changing concentration. I have again my favorites. Equilibrium reaction N2 plus H2 becoming ammonia. My equilibrium, first situation. And when I calculate correctly, I have a K of 0.0602. And now I'm going to add N2. And my new equilibrium values are here. And when I do assess the K, it's exactly the same. And that's what I expect because temperature is constant. K is only changing when temperature is changing. So what we can say, we added products on the left-hand side, so for reactants, and you see it will shift to the right to Na3, so to products, because you can see the concentration of H2 is lower. Also, for Na3 is higher. So what we say, when we're adding reactants, my equilibrium shifts to products. Adding on the left-hand side shifts to the right. Opposite, of course, is also true. When I'm adding products, it shifts to reactants. So adding on the right-hand side, shifting to the left-hand side. And that's the Chatelier's principle. Adding reactants shifts to products. Adding products shifts to reactants. This is by adding. But what's going to happen when we remove compounds? The same system. N2, H2, becoming ammonia. What happens if I remove Na3? Let's think about it for a second. If I remove Na3, then my reverse reaction, will be more difficult because there's less Na3. So, taking away products, I have less of my reverse reactions. So, I have less reactions to the left. So, the amount of reactants will decrease. So, less reactions, more products. When I'm removing products, it shifts to products. Also, Chatelier, when I do something, the system do the other thing. If I'm removing products, I'm shifting to products. If I'm removing reactants, shifts to reactants. Make sense for everyone? So removing Na3, reverse reaction is more difficult, so I have more reactions to the right instead of left, because I'm removing products. So removing products, equilibrium shifts to products. Removing reactants, equilibrium shifts to reactants. This is about Le Chatelier's principle, talking about effect of change in concentration by adding or removing compounds. What I want you to do now, study chapter 70.3a, only for the change in concentration. There's a worksheet on Schoology available for you. Has one more practice with ice tables and some questions about change in concentration. Tomorrow we continue also with Le Chatelier's principle, and then we're going to look at change in volume. Okay guys, that's it for today. Have a good day. Bye-bye.